All right, in this last video, we're going to look at an application problem, something that you might see in your physics class. So we're going to look at projectile motion. This last example up here, I did in the notes, so you can take a look at that on your own. But let's look at projectile motion. So projectile motion, they're parametric equations of the path of the projectile fired at an inclination or angle of theta to the horizontal. So measure it like this, with an initial speed of v sub 0 from a height h above the horizontal. And those parametric equations are this one and this one. So there's your initial velocity times cosine of theta, all of that times t, and then the y, negative 1/2 g t squared plus the initial velocity times sine of theta, all that times t, plus h. So there's a lot of stuff happening in there. So t is time, g is the constant acceleration due to gravity, and you're either going to use either the 32 feet per second squared or 9.8 meters per second squared, and it just depends on what your units are to tell you which one of these it's going to equal. Okay, so let's see how all of this kind of comes together and works. So Greg throws a ball at an initial speed of 128 feet per second. So right there, that's your V0 from a height of 192 feet. So that's H at an angle of 30 degrees. So there's your theta. So find parametric equations that describe the motion of the ball as a function of time. So all they want you to do is figure out the equation for x, figure out the equation for y. But first, you need to know which of these two values for g you're going to use. Are you going to use the 32 or are you going to use the 9.8? Well, it all depends on the units. They're talking about feet in the problem. So let's use the one that has feet in its unit here. So we're going to use the 32. So you know every value to plug into these, the only thing that you don't know is the time. So x is going to equal 128 times cosine of 30 degrees times t. And then the y, negative 1/2 times the g, which was 32, t squared plus 128 sine of 30 degrees times t, and then plus your 192. And the only thing left to do with these is to just work them out. Because cosine of 30, that's root 3 over 2 times your 128. We give you 64 root 3 t. And then for the y, just simplify them down. So that would be negative 16 t squared. Sine of 30 is 1/2 times 128 is 64 plus 192. So there's your parametric equations. So this is how the y value is changing as it goes up and down, and this is how the x value changes as it goes off to the right. So how long is the ball in the air? So we're going to use the y equation to tell us that, because it's in the air for as long as the ball is in there. You know, it isn't on the ground. Well, we know the height of the ground. We don't know how far away it is from where he threw it, so we can't use the x, but we do know the height of the ground because that's going to be 0. So we're going to set the y equal to 0 and solve for t. So it's a quadratic equation. So let's go ahead and divide everything by negative 16. You don't have to do that, but if you can make your numbers smaller, that'll make it easier to solve. So I can factor that. So t is equal to 6 and also negative 2, but we don't deal with negative time. We're not time traveling back into the past. So just any negative t value, just toss out. So t is going to equal 6 seconds. All right, part C, when is the ball at its maximum height? So with projectile motion, it's always some sort of a parabola shape. So it wants to know, well, when is it at the top? Which means it's asking for when is it at the vertex. So we have two ways that we can get it. We can either use t is equal to negative b over 2a from your y equation. So that would be negative 64 all over 2 times negative 16. So it ends up at 2. So 2 seconds, then that's where it reaches the top, and then after that it would start to head down. So that's one way to go. It's not hard or whatever, so you can use that method. The other way is you can average the 2 times in part B. Because you came out with 2 times, it's just one of them is negative. Well, if you still average them together, so negative 2 plus the 6 divided by 2, that still gives you 2. So you can go either direction. You can do them both if you wanted to kind of double check your answers, but either just one of them will work. Okay. D, what is the maximum height of the ball? Well, we know when it occurs, so now you just got to plug that into the y equation and see what the height is. So negative 16 times the 2 squared plus the 64 times 2 plus 192. So if you just work that out, that's going to equal 256 feet. Okay, part E, when does the ball reach a height of 240? Well, just like the ground, we knew the height of the ground was 0. Well, now we know the height is 240. So take your y equation and set it equal to 240 and solve it. So it's still quadratic, so still set it equal to 0. So 192 minus 240 is a negative 48. So I'm going to do the same thing I did last time with the quadratic. I'm going to divide out that negative 16 because I can. And then that's a little bit easier to work with. So 2 minus 3, 2 minus 1. So t is going to equal 3 and 1. Let me write that out in a little bit nicer way. So 1 second and 3 seconds. So we get to keep both of them because they're positive. So how is that possible? Well, it's because when you threw it, it hit 240 feet on the way up, and then it hit 240 feet on the way down. Because 256, that's the top. So I had to have hit 240 feet twice. All right, and then the last part, part F, determine the horizontal distance. Well, anytime it's talking about a horizontal, that's going back into the X. So it wants to know how far does it travel out this way. So what would this X value be way out here? Well, we know how long it's in the air, which was your 6 seconds. So we're going to plug that in for the t. And so x is equal to 384 root 3 feet. All right. So that's how projectile motion is going to go. And that's going to do it for the section and also the chapter. So let me know if you have questions, if you want to work out anything else, if you're not sure why something is the way it is, please let me know and we will work it out together. So hope you guys enjoy the rest of your day, and I'll see you guys in chapter 12.